Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to be going over how to figure out or propose a possible mechanism for given rate law given and reaction given. So let's get into this. Okay. So for this problem, we're told propose a mechanism consistent with the observed rate law of the rate is equal to K times the concentration of NO2Cl. And then they give us this reaction here, right? So we are given the rate law. Rate is equal to K times concentration of NO2Cl. And then we have this overall reaction. And so we need to find a mechanism. Okay, so we notice right away that this is breaking down into these two. So, and you only have two of those, right? So this is a kind of decomposition reaction. So we kind of see that in the rate law as well. The rate is only dependent on the concentration of NO2Cl, and we only have NO2Cl as a reactant in the overall reaction. So our mechanism is going to involve a decomposition. So what we can propose here, and you can see here that the Cl kind of breaks off to form Cl2, leaving NO2, and we have two of those. So let's try the first step would just to take one of these, NO2Cl, and have it decompose into NO2 plus Cl radical, right? So the radical, the Cl comes off as a radical. And so this is highly unstable. So this is want to react quickly, right? So this here, we can see this maybe as a slow step. So step one, and this would be slow. And then this is going to quickly react. So we would say so then we have two more. So then another one, NO2Cl, would react with the radical Cl to form this. So the chlorine radical will react with the chlorine here to pull that off. And then we'll end up with NO2 plus Cl2. And this would be the second step, step two. And this would be fast. Okay. And so if we add these together, we will get the overall reaction. So the chlorine radical on this side would cancel out, leaving us with two of these. So that would give us two NO2Cl, giving rise to, and then we have 1, 2 NO2s on the product side, and 1 Cl2 on that side. So these two do indeed add up to the overall reaction. So that's one thing. That's check that box. So for the mechanism, what about the matching of the rate law? So if we say that this is the slow step, that's the rate determining step. So the rate law would be determined by this step here, or I'm sorry, this step here. So if we write the rate law, let's go ahead and write the rate law here. So then the rate law for step one is going to be equal to the rate is equal to K, and then this would be, say, K1. So K1 times, and the only thing we have here is the NO2Cl, so it would be the concentration of NO2Cl, which is what we have here. So that matches as well. Now, what if we said that this was the slow step, right? We could then see here, well, if this was the slow step, we would have NO2Cl right here was Cl radical. So then our rate law for that step would look like this. So rate, and we'll call this K2. The rate of 2 is equal, this is the rate of 1. The rate of 2 would equal K2 times the concentration of NO2Cl, and then we'd have to multiply that by the concentration of Cl radical, right? So then we would have this intermediate in there. We would need to get rid of the intermediate. And then to do that, we could say, okay, let's say this is the fast step, and let's say it's an equilibrium fast step, right? So we have a K minus 1, or K minus 1. So what we could do is then do the normal thing that we normally do, right? So this would be fast, and so that would be at equilibrium. So then the rate 1 would be equal to the rate of minus 1. And then the rate law for 1 would be equal to the NO2Cl. So it'd be K1 times NO, the concentration of NO2Cl squared. Oops, I'm looking at the wrong one. Sorry, not squared. To the 1 here, right? So that would be rate 1 equals K1 times NO2Cl. And then if we do the reverse one here, then it would be rate minus 1 equals K to the minus 1 times the reactants here. So if we're going reverse, and these are considered the reactants, so it would be concentration of NO2 times the concentration of Cl radical, right? So if the rate 1 is equal to rate minus 1, so these two are equal, so that means these two must be equal. So then we set those equal. So K1 times NO2Cl is equal to K minus 1 times the concentration of NO2 times the concentration of Cl radical. So then we have these. So to substitute in the Cl radical here, we could solve for this. So that means we would divide both sides by K minus 1 and concentration of NO2. So divide this by K minus 1 times concentration of NO2. So then these cancel out. And what you get is this is equal to this. So we could then take this and substitute it in for this, but right away what you notice here is you get the rate is equal to K2 times K1 over K minus 1 multiplied by concentration of NO2Cl times the concentration of, let's see here, squared, because we're multiplying by NO2Cl, so that would be squared over the concentration of NO2, right? So here you can kind of see that the rate law here is not really going to be looking the same as the given rate law that they gave us up here. So K times NO2Cl. Here we got K, this would be K overall. K is equal to NO2Cl squared divided by NO2. So if we said that this was the fast step and this was the slow step, then we're getting something that's quite complicated and not really looking like it would, looking like the rate law they actually gave us. So, but we saw that if the first step is the slow step, then we do get the rate law that they gave us. And so this is a legitimate possible mechanism for this reaction, because it gives you the the two criteria for a good mechanism. One, the mechanism has to add up to the overall reaction, which is what we showed here, right? So these two add up to this one, which is the overall reaction they gave us. And if this is the slow step, then we saw that this slow step is the rate determining step and therefore determines the rate of the overall reaction. So if we get the rate law for this one, we get the rate is equal to the concentration of this times K1, which is the rate law that they gave us. And so that, ladies and gentlemen, is the end of the video. I hope that was helpful. If you enjoyed this video, if this helped you in any way, then please like the video, share the video, hit that like button. Also, subscribe to my channel. Please do me a favor, help me out, spread the word. Also, make sure you hit that notification bell right up there and click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have any problems or questions you need help with or a topic you want me to cover, just put it down below. I would do that for you. Thanks for joining me and have a great day.